All right, this is problem 940, and it says you need to design an industrial turntable that is 60 centimeters in diameter. So let's go ahead and D equals a 0.60 meters. And has a kinetic energy, EK, of 0.250 joules when turning at 45 RPM. So omega is 45 RPM. RPM is our common notation, which really is revolutions per minute. But nobody wants to write all that, right? Nobody. So we just do an R and a P and an L, right? It's become common parlance in, among the machinists, right? And RPM, right? All right. What must the moment of inertia of the turntable, what must be the moment of inertia of the turntable about the rotation axis? If your workshop makes this turntable in the shape of a uniform solid disk, what must be its mass? Okay. So we're given the diameter, we're given the kinetic energy what we want to achieve, and we're given omega in RPM. And what we want to know is the I. So we're going to use EK equals 1/2 I omega squared. But we can't use RPMs, right? We need to get radians per second. So I'm going to take that 45 RPM and multiply it by 2 pi radian over 60 seconds. Let's see. I don't know what that is. 45 times 2 times pi divided by 60. 4.71 radians per second. Is that what y'all got?
4.71.
4.71 radians per second. Okay, that is omega. Now we have a 0.250 joules equals 1/2 I, and then 4.71 radians per second, quantity squared. So, I has got to be, let's see, 0.25 times 2 divided by 4.71 squared. 0.2205. 0.0225 kilograms meter squared are your units for moment of inertia. Kilogram meter squared. All right. Now we have what must be its mass. Okay. So they're going to. It says if your workshop makes this turntable in the shape of a uniform solid disk, and we just did the moment of inertia for that. So what must be its mass? So 0.0225 kilograms meter squared equals 1/2 mR squared. So we're finding mass, and we know R is 0.0225 kilograms meter squared times 2. And then I'm going to divide by R squared, which is going to be 0.30 meters, quantity squared, equals mass. So, .5. 0.5 kilograms. Is that what everybody got? Seems like a weird round number to get. All right, to recap. We're giving a pretty simple problem. We're giving a kinetic energy. It's just a rotating disk. There's no translational motion here. We're given angular velocity, but in RPM. We simply convert that to a radians per second by using this conversion, 2 pi radians over 60 seconds. And once we got that, we put it in this equation. We knew this value. We pop that there, and we solve for I. Once we had I, we knew that the problem said we model it after a solid cylinder. So once we had I, we set that up to 1/2 mr² and solve for the mass. Thank you.